welcome to our fourth episode of Factoring Polynomials. Today we're going to talk about one of our two special cases, something called a difference of two perfect squares. Now when you hear the word difference, you should automatically think of subtraction. You want to have two terms that are being subtracted. Those terms themselves must be perfect squares. So you have a squared minus b squared. Okay? So when you break it apart, you have, what's the square root of a squared? A. You put a first in each one of the two binomials. And what's the square root of b squared? B, which you put in the second term. Just remember you have to have a plus and a minus. And that's our formula. So let's get going on some of these problems. So when I look at this, I see two terms. What I don't see is any greatest common factors, which is good. So next step is 4n squared a perfect square? What I like to tell my students is, ask yourself, what do you have to square to get 4n squared? Well, I need to square 2 to get 4. And I need to square n to get n squared. Minus, which we need. And then, what do you square to get 9? Well, I have to square 3. So this step right here is not factoring. What it is rewriting this original polynomial so that we see what are the two things being squared. Some teachers might say, just take the square of the first term and the square of the second term. And that does work as well. Now, the actual factoring comes in when we write our two groups. And we're going to have two binomials. The thing that goes first in each one of these is the first term that's being squared, this inside. So we're going to put a 2n here and a 2n here. The last thing that goes in each one of these is what you're squaring in your second term. 3 and 3. The final thing you have to remember are the signs. Now, does it matter if I put plus and minus or minus and plus? No, it doesn't. So I'm just going to put a plus here and a minus there. If you ever want to check your factoring in any of these cases, you can always FOIL back out. So let's take a look at our next problem. We have 8a to the second minus 50b squared. I see two variables, but don't let more than one variable scare you. We're still going to look at the same thing. Is this a perfect square? Wait, no, it isn't. But, you know what we forgot to do? Is there any common factors? When I look at 8 and I look at 50, I know that 2 divides into both of those. So I'm going to factor out a 2 and get 2 times 4a squared minus 25b squared. And again, whenever I take out GCF, I always like to circle it and bring it down as part of my final answer. Then I can focus my attention on just what's left. So the 4a squared minus 25b squared. Then let's ask ourselves, is 4a squared a perfect square? And it is. You square a 2 to get the 4, and you square an a to get the a squared. Minus, is 25b squared a perfect square? It is. You square a 5 to get 25, and you square a b. So even though we have two variables, they are still completely separated from each other. We have one thing being squared minus a second thing being squared. We have a difference of two perfect squares. So we set up our two groups, our two binomials. 2a goes in the first spot in each one of these. 5b goes in the second spot for each one of these. And then we write a plus and a minus. And again, it doesn't matter whether or not you write the plus or the minus first. Just remember to write it with your final answer. And 2 as a common factor is part of the final answer. So it's really 2 times the quantity of 2a plus 5b times the quantity of 2a minus 5b. And that is our final answer for this difference of two perfect squares. This is a strategy that tends to pop up a lot in many different algebra examples, so keep your eye out for it. Two terms that are perfect squares and a difference between them. Hopefully you enjoyed this lesson and it'll help you out with your homework.